Here is a topic that gives students nightmare: binomial theory. This topic is a very interesting topic. First of all, what is binomial theory? It is a theory that expands a binomial expression. So we have a binomial expression like this. So this is a binomial expression. We can expand this using Pascal triangle. I know many of you don't know what is called Pascal triangle. This is Pascal triangle. Okay, you have when n is equal to 0, when n is equal to 1, when n is equal to 2, you have it like a plus b raised to power 0 will give us 1. Okay, then a plus b raised to power 1 will give us 1, 1, which is a, the coefficient of a is 1, the coefficient of b is 1, you have 1, 1. Then let's say this, a plus b raised to power 2, we can quickly expand this using a plus b method. Okay, a plus b times a plus b, we get a squared plus 2ab plus b squared. Here we have 1, 2, 1. So we can from here and expand this binomial expression. We can as well use binomial theorem to expand binomial expression. So we are using Pascal triangle now. Okay, Pascal triangle. And this Pascal triangle, you see, 1, we've gotten it when it is raised to power 0, you have 1. A plus b, when it is raised to power 1, you have coefficient of a 1, coefficient of b 1. A plus b raised to power 2, you have a squared plus 2ab plus b squared. The coefficient of a squared is 1, coefficient of ab is 2, and coefficient of b squared is 1. So we don't need to have this again. Rather, we have 1. Okay, let's see. 1 plus 1 is 2. You see, you write 1, 1. Let's go again. 1 plus 2 will give us 3. Okay, 2 plus 1 will give us 3. Okay, 1 plus 2, 3. 2 plus 1, 3. You have 1, 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1, 1. So we can actually use Pascal triangle. This is called Pascal triangle. It is the coefficient of the binomial expression. Okay, when you have expanded it, the coefficient is called the Pascal triangle. The coefficient is called the Pascal triangle. So this is, we can even proceed by saying 1 plus 4, 5. You write down 1, 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. 1, 1. As the case may be. This is a shape of a triangle. That is why it's called Pascal triangle. And the scientist who discovered it is called Pascal. That is why it is named after him. And we have him as Pascal triangle. Okay? So we are going to look into some examples on how we can use Pascal triangle to expand a binomial expression. Before, in our next class, we can now talk about basically binomial theorem, how we can use it to expand binomial expression. Okay, let's see how we can use Pascal triangle to expand binomial expression. Good. If you are asked to expand x plus 3 raised to power 4, expand this using so what we'll have to do is, this is 4. We start with 1. 1, 1. 1 plus 1, 2. 1, 1. 1 plus 2, 3. 3. 1, 1. So 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1, 1. Okay? So from here, we stop at 4 because the power is 4. Stop at 4 since the power is 4. So from here, we can now say x is A, while 3 is B. So x is the first term here. So we take x to, this x, we take all the power of 4. So we write x raised to the power of 4, and the coefficient is 1. So 3 raised to the power of 0. Now, 4 is the coefficient plus 4, x raised to the power 4 minus 1. So x will start reducing by 1 as 3 will be increasing by 1. So 4 minus 1 is 3 as 3 will be raised to the power what? 1. So what is the coefficient again in the next term? 6. So we have x, so 3 minus 1 will give us 2. As x will reduce by 1, 3 will increase by 1. So here we have 3 raised to the power 2. So we continue again. This is another coefficient, which is 4. Okay, so 4, we have x reduced by 1. So 2 minus 1 is 1. Then 3 will be increased by what? By 1. So we have 3. Another coefficient is here is what? 1. So plus 1, x is now 0, as 3 is raised to the power 4. So from this plus, now for this point, we now say that anything raised to the power 0 is 1. 1 times 1, 1. So here we have x raised to the power 4 alone. Plus 3 squared is what? 3. 3 times 4, 12. So 12x raised to the power 3 plus 3 squared is 9. Okay, 9 times 6 is 54. 54x squared plus 3 raised to the power 3 is 27. Okay, we multiply it by 4. 4 times 7 is 28. You write that 8, carry 2. 4 times 2 is 8 plus 2, 108. So we write 108x plus x raised to the power 0 will be 1. Anything raised to the power 0 is 1. 1 times 1 is 1. 3 raised to the power 4 is 81. So from here, we say that the expansion of x plus 3 all raised to the power of 4 is equal to this. So this is the final solution using Pascal triangle. Using Pascal triangle. Okay? In our next video, I'm going to show you how we can use binomial theorem to explain and expand binomial expression. Bye!